Hello, everybody. What's up? I'm Papa Bale, and this is the counter-rotating Utron. Well, half of it anyway. The lower half, I have it magleved. Look at that spinability, man. That's awesome. And it's on the outside. The inside can run simple. Just setting up those mechanics is, half the battle, and it's not hard to do. It's just need a few magnets, both your setups, and yeah, it's pretty straightforward. Excuse me. Yeah, it's not. As soon as you, everybody. I don't even know. I would say as soon as you catch on to how it works, it's easy to build. But as you can see, I'm still struggling with the space. There's issue with the space. So what I was thinking about is taking all this stuff off the top, right? And making a plate to go on the top about 8 inches. So it would go out to here. And it would be flat all the way across except for where the shaft is, giving us a lot of space to just spread that stuff out and make it look nicer. Or even if we end up connecting things in a different way. You know what I'm saying? Hello, hello. Hey, Mike. Thank you, man. Appreciate it. All right. So turn both these switches on. And what that does is it turns on the circuit with the battery. And then it also turns on the circuit that's being run by the cat bank. So now they're both running off of the one battery. Actually, the cat bank is hooked up to the 4 pickup coils. So that's what I think is the most intriguing part of this, is that because the coils are in proximity and they're the same size. That's the important part, man. When they're the same size, they really interact with each other well, like really well. When the coil hits, that pickup coil gets that full saturation. What's up, Yanni? Faraday. What's up, guys? Heck yeah, man. So, dude, you got me on the pesos again, man. Dude, thank you. Thank you. I've now learned how to hook them up correctly. Oh, man, that's so good. And, well, in series and parallel. So like across the coil in series, very, very nice for voltage. And I also learned like hooking them up parallel is better for current, so I hook them up both ways. But I don't know. I'm just playing around with them right now. Heck yeah. All right. So, which one is this? This one is, all right. So this is just gathering from the magnets. The one that's hooked up to the cat bank, the on-off switch hooked up to the cat bank is on right now. So anything we're getting off of the magnets right now is going straight to that one circuit that's hooked up to the cat bank. And as you can see, even like right now, it's not enough to make it go faster. But I do believe there's a factor of longevity kicking in here. Because at a given point, the momentum, and I do believe there's a point of equilibrium there, the momentum is going to slow down to the point where you're going to get more thrust from the mediocre energy going in than the momentum has. And that doesn't last very long. That's like the point of equilibrium. When that happens, it doesn't really happen. It's the shift. And see, I don't even know, like right now, it might be happening right now. Like but I think it's got to be going a certain speed. Let me explain the coils. The coils are, the pickup coils, I mean, are literally, I want to say 1.5 inches away from the magnets. And the drive coils are 3/4 of an inch away. So without the battery, basically what I'm saying, without the battery, you saw just right now that it's gonna stop like pretty fast. But with that transformer energy from like, you know, the coil hitting, so you turn it on, when you hear that noise, you know that it's hitting. Yeah, and you could tell that the energy was going straight through the cap bank and right out the other circuit. But at that point, there's nothing going on. So there needs to be a continuation. So there needs to be more space. You know what I'm saying? So that doesn't have to be the end of it, is what I'm saying. The energy from that battery can run this one, it can run this one, it can probably run another 3 or 4 of them. You know, or, you know, I do have super caps coming. Super caps. And I'm planning on replacing the batteries with super caps, if at all possible. That would be awesome, in my opinion. And I believe that if that be the case, you see, the thing is, what I was hoping was with the increase in volume, amount of turns, and the same amount of mass. So I was thinking, since the mass was the same for both the pickup coil and the drive coil, that having the more turns would generate more electricity when you know, the smaller one of the drive coil would hit. You know, having that extra, I don't want to call it mass, because it's not extra mass. It's extra turns. It's extra length. Call it length. You know, it's extra length. And I don't know, man. It's weird how it all kind of came together. I mean, for the exact numbers, the drive coils are 5.2 ounces, and the pickup coils are 4.9. I mean, and then if you add those two together and divide by 2, you get that number that's like 5.1 or 5. Something like that. Something like that. They're really, really, really close. I would consider the difference negligible, considering what I'm trying to do. I think it just kind of fell into place. And what determined the size of all of this is the bobbin. The bobbin is the only thing basically that I bought that's actually part of the structure. And I bought it in that shape, and they're great. They're really, really awesome. I mean, just to come up with this proportion, This ratio, man, I don't even understand how it worked out so well. Yeah, it worked out so well, man. And I knew these bobbins were destined for greatness, man. I love them. I love them to death. And they're so tiny, but I mean, oh yeah, I remember what I wanted to show you guys. If you want to see it, we will show you. We want to turn off the cap bank, and we want to turn on. Oh, that's backwards. Okay, this one goes off, and this one goes on, and then now the cap bank lights, if you can see them, are off. They're like there's no light in them, right? And it's all hooked up to the pickup coil. So this is how you can tell whether or not your pickup coils are picking up anything. If those lights go red, you've got substantial energy in there. Here, let's see if we can hook up. Um, hmm. 13.4 volts and dropping. That's awesome. I just got to say right now, that's awesome. That's DC voltage. About 13 volts. After it took me all that time to hook it up, too. Like, that's so cool, man. This is it. Finally, I made something that like works the way I want it to. Because once it gets jolted and it's going fast enough, you do get a lot of energy from the magnets because your field expands as the spinning increases. And the faster it goes, the more magnetic energy it's going to pick up. And that stuff there's no stopping that really, except saturation. Saturation will stop that. That's when you reach your potential, and there's nothing above that. And once you get the electricity to take all the paths, instead of just the path of least resistance, you've reached your saturation level. That means you can make anything work. All right, but we turn this on here. Now they're both running. I don't want to let it run too much, man. I feel like all that stuff is just going to go whoosh and fly right off of there. So that's what I'm saying. Like the next iteration should just be a plate that I put on top of the batteries. I remove all the stuff, remove the breadboard and all of that, and you just have the wires of the battery sticking up out of the plate. Be perfect. And the plate would stick out to right about here, about 7¼ inches out, or 7.5. Let's call it 7.5 inches. So, or 7 inches. Got a 1/2 inch on each side. But 7 1/4 inches is probably better. We're looking to maximize the amount of space we can have without it interfering with putting that cap on the top. You know what I'm saying? We don't want to make it stick out past the magnets, because then there's a chance that that cap won't fit. So it's got to be inside these magnets, and there's got to be an angle, you know, drawn up that we can maximize space. And then probably just by doing the top, I'll figure out what that is. That should be awesome. I mean, seriously, people will think it's spinning on its own. See, I don't like doing it that way, but it'll move that way for sure. Because then I get all discombobulated and it starts going really, really fast, and I can't figure it out for some reason. So I always try to make the rotor go this way so I can stick my finger in and just stop it. I don't know, man. It's like I used to be really predominantly right-handed when I was younger. And now it's like I'm using my left hand to do a whole lot more stuff. And I use my right hand too, but I'm using my left hand like a lot more. They all have a plastic core. There's a peg on the rotor that they're resting in. So I would call it an air core, since it's not a conductive core or a magnetic core. It's definitely an air core. But it is plastic. If you want to talk literal terms, it's resting on a peg. Or they're connected on a peg. Yeah, I can see how that isn't going to be possible with it going like really, really fast. I don't even think it'll go really, really fast before it breaks in half. Anyway, but I love playing with it. And I mean, the circuit is really, well, I have it written down here somewhere. It's a really simple circuit. Yeah, it's not Bedini. It's missing a few things. I just call it the 1, 2, 3. It's got 1 base connection, 2 collector connections, and 3 emitter connections. And that's it. That's all you need. That's why all the battery stuff can fit and be in the rotor, because it's such a simple circuit. And I'm sure there are other ones that are equally as simple. But that's the one that I use and that I know. Now, what I would really like to do, you know, you would think that with the coil, like when they're moving fast, that they're generating quite a bit since they're in series from the magnets. That's what you would think, right? So I'm trying to figure out, I think this way. And then any that gets generated should stay in the cap bank and illuminate the lights a little bit. So both circuits are off right now, and that should allow the energy to pool up in the cap bank if there's any coming from the magnets in the first place. I'd say there is, like very little bit, with it going that fast. Very little bit. Because again, they're an inch and a half away from the magnets. Haha. Thanks, Yanni. Appreciate that. All right. Sorry, I got a whole new configuration. As you can tell, the table and everything is in a different place. The TV is like way on the other end of the room, so I can't really see what's on it, but kinda, a little bit. All right, what I'm trying to do is see if there's any illumination. I do think I see a little bit, but maybe I'm being hopeful. No, I do. A very little bit. There's no like radiance. It's just like a dim, very dim. So that means that when I spin it with that one on, that little bit of energy filters right back into the circuit. And since it isn't coming from, see, but you know it's not working because the motor starts spinning in the synchronous direction. Nah. See, there it goes. When it's running at all, it'll go in the opposite direction of the motor or rotor. And so it's not running all the time, and it's not running, see, it'll change its direction, the outer shell, when the actual motor is on. Yes. But this is not from a battery. This is totally from the cat bank and the pickup coils. This is awesome. I'm intrigued, man. This is blowing my mind. Because it actually, like every 3 seconds, it'll start going the opposite direction. So that, huh? Maybe I need two of these Neos. Check this out. So we don't have to change anything else. We just make a hole for 2 Neos. And that would work great. I think that would work really good. Have 2 of these Neos in a square instead of these little rectangle squares. Like a cube, a big old cube. That's what it would be. And that might actually work really, really, really good. Here, let's start that up one more time. Yeah, we need more magnetic. That's one way to fix this, is to have a stronger magnet right here. Because the rotor is probably not going to change that much more. It's going to have its plate on it, and then maybe we put a cap on it, like a little hood, like a dome, right? And then we put our conal crown on it. Bam. Like, yeah, man, that's gonna be so cool. Yeah, man. Yeah, it's definitely a snow globe, bro. Hell yeah. Let me show you what it does when it's on. It's definitely a snow globe. But I run 2 circuits with one battery, one connection to the battery. With that torque, man, step back. Huh. No, I'm kidding. It's not bad though. So like I was explaining earlier, you're gonna have a larger plate, a flat surface to spread all this junk out on, right? So that it all looks nice. You're gonna glue it down, make it so it won't fly around and stuff. And then you put a cap on it, like a little dome on this, and then you put a little cone, a big cone that will attach to the end of this cone. And then the shell will look like it's spinning, because it kind of is, you know. But, you know, before I let it rip, man, I got to get a lot more sturdy setup. I just wanted to show people that I've been, you know, moving along, and I've got, you know, pickup coils now that function very well. They are mini transformers. Since they're in proximity to the drive coil, they get an immediate boost. And they're in series, so that boost can happen anywhere. And it's going to be good. All right, so our cap bank is empty right now. I'm going to spin it. Every chirp, you're getting a large. See that? Look at how much energy is in the cap bank now. It's like, wow. That's awesome. But when you turn the second circuit on, all that immediately goes away. But it's a throughput then. It's like it takes the energy from the coils and it puts it directly into the circuit, and it runs it very well. That's all DC. Very well. Now I have 3 more batteries, well, 2 more batteries in here that can work. I lost the end off of one of my batteries and it's gone. So I bought another one, and the battery should be here in about a week. Yeah, man, I'm like, dang, I was gonna run 24-volt circuit or 36, 48. You know, I got options here. And then, but yeah, that was the main thing. I was going to do 24 volts with this. That's 12 volts right there, man. It runs really good on 12 volts, but I'm curious. I'm curious what it would be, and if it would damage the circuitry or not. I love that, man. Both of them are hitting like magic. Wow, dude. That's impressive. That is impressive, like power there. Heck yeah. So I was thinking about doing twice that power, and then I was thinking about doing, and then still having to stop it with my finger. I was like, hold on a second, wait a second. What if it even decides not to slow down at 24 with my finger? It's close enough to running away like right with this, with with 12 volts. It's like, wow. So if you can, you know, figure for a second here with a cone top on it, that is, you can remove it and put it on. You got your circuits on, you put your cap on, and you just spin it the way you want to spin it. That would never stop. I mean, now that I think about it. So yeah, I've been looking at wireless, um, toggles that run on, probably their own power supply. So basically like an RC remote control receiver on the on and off switch, basically. So when you turn it on, you can turn it on, flip the switch, you know what I mean? And then when you want to turn it off, it'll flip it off. It's something that you press a button that you don't have to have anything connected to it. That's what it needs to be like completely done. Yeah, yeah. It's all right. I love it, man. Yeah, I gotta hook it up. Um, get these other wires in play because they keep whipping me and they're freaking me out. There's nothing wrong right now. It's just those things keep whipping me. It's freaking me out. So I gotta like hook up the other two circuits or hook up one more circuit in at a 180. So what I'll do is I'll take this drive and hook it to this drive and hooks this trigger coil into the drive and have this trigger coil be the trigger for the whole thing. And that one would save a bundle of cost per revolution, like a trillion tons. If I would have built the other one the same way, but I wanted to do the cap bank, I wanted to use the pickup coils. You want to see? I'll show you. Oh man, these ends are a little short now for making a 180. I think I can do it though. This is this one. We'll come to this one. I just need a little bit of wire to put in between them. Some 20 gauge. I made them shorter because they were way too long, and I didn't make them long enough. So I need to put an extension between them. And this works just fine because it'll link to this breadboard, put the other circuit right here. And put another circuit right here. And that'll be all 4 coils. But if I do the 180 thing, then I only need to put 1 circuit on here. Thank you, sir. So maybe it'll be an octagonal shape because this is an octagon currently. So we'll make it go octagonal like, because I'd love to have like a smooth surface to put everything on and just adhere it to it. Adhesive, even if it's a spray adhesive, and just something that'll hold on to it. This does a pretty good job what I've done right now. Holds on real good, but it's not smooth. It's not smooth. So I'm definitely gonna print out a bigger surface, smoother surface, remove all that, and oh man, I have a good feeling about it. I think it's gonna turn out just fine. Let's that no. All right. So let me show you guys the circuit real quick. I think if I put propeller blades on here, it will fly just fine. But will it fly from its own existence? I think it has to be a different shape for it to fly, really. Won't fly at 12 volts, that's for sure. But I do have the option to go up to 48 or will have the option once that new battery came. It's weird because I had it clipped, and then all of a sudden I was holding on to the end of the battery, and I was like, what just happened? And one of my batteries lost its negative clip, or its negative wire, its lead. Hell yeah. I, yeah, I've noticed the solid state battery. Yeah, that's cool, man. I think it might work well in this if I'm trying to make it run itself. That might work well with my creation here. Uh, anyway, I do have some super caps coming that might work. I'm not sure though. They're little square ones that are like 10 farad, but they've got the longer ends, so I'll be able to clip them or put them onto something clippable. All right, cool, man. Yeah. Well, let me know when you get that up, dude. I'll probably end up buying one of those. Sure, maybe a couple of them. There's lots of stuff on my list though, so but that's important. Mm. Now I wonder if I put a 10-volt capacitor. How would I hook that up on the coil to slow everything down a little bit? That's cool, man. How close are you to, or what have you found out, I should say? A lot, I know. 3 years, man, that's a lot. Oh, yeah, I could imagine. But what's real, though, Mike? You know what I mean? What's real? I know this is real. Um, the only reason that I can prove that it's real is because the red lights turn on. There's definitely indication of electricity being generated from the pickup coils, which is, in my opinion, impressive. Especially that I'm utilizing two types of collection on the pickup coils. Dang, bro, life, that's shelf life, right? Yeah, yeah, that's cool. 20 years, man. That's more than anything out there right now. Run life, Jesus. Wow, dude, that's so cool. And what voltages have you produced? And I mean, you've made it up, so you can produce like at like a just-in-time manufacturing style voltages too. So like if I need more than a 1.5, what if I need like a 5.5? It's not quite a 6. I don't know. It's important like that, but so that's one. That's just one. Huh. That's awesome. And there you got lots of buildup in the cap bank from the switch being off, and turn the switch on. And you even heard it chirp. One chirp. Oh man, that's great. Hell yeah, man. So like yeah, I'm super stoked about everybody stopping by, checking this out, man. I think it's pretty close to being done in regards to what's going into it. I think I'm going to shape it up a little bit. I'm going to start by trying to print a plate. Need to come up with the right size plate so that it doesn't interfere with anything. So I think it's going to, we'll see what it does. I think an octagon is where we're going with this thing. I'm making 8 inches in diameter, and it should give me the room I need on the rotor to, put everything on there and make it look nice, or nicer, I should say. I'm still going to glue it down. Still going to glue it down, man. There's just, it's not that much stuff, but it'll look better with it spread out a little bit more. Yeah, man. I'm sorry I missed that. I woke up this morning and I saw that there was a show that went on like 16 hours ago. And I was like, oh, man. Maybe it was a different show. I'm not sure. Mm. See, you still got to throw it like pretty hard to get it going. It's kind of barbaric, but I don't mind for right now. All I gotta do is have some way to. What I want to do is just have like a little thing that I push down, and it's like a little flap, just like my finger, that'll slow it down. Nothing too fancy. Except, if you finish it, then it's got to have the remote control. It's got to be remote control. These two switches have got to be controlled remotely. That's it. That's all they need. That's all that you need to stop it is, remotely control that toggle switch. Thank you, Faraday. Thank you. Heck yeah, man. So I was thinking about getting graphene for my switch. You know which switch I'm talking about? My paperclip, man. Just to coat that whole thing in graphene. But I want to get the right stuff. Yeah, I want to get. Here's my latest version of it. I want to coat all this in graphene and these two ends in graphene. Yeah. Should be cool. I mean, it should help out a little bit. Short of being gold or silver, I think that's the route to go. You know? Huh. Hmm. Um. Wow, this thing is heavy, 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 man. It's got to be at least 4 or 5 pounds. Probably more. I'm probably like lowballing it. Let me just think. It's 40 ounces of copper. So 16, 16, 2.5 pounds of copper. And then it's got 4 batteries in there. So it's like 3.5 pounds, I want to say. Maybe more. 4 pounds. Yeah, I was right on. So this is running just the pickup coils to the cap bank to the second circuit, and that's flowing. So we're not going to get anything that's being generated right now is being filtered through to the second circuit. So I already know that just me spinning it with my hand isn't going to be enough to, make it work. And I think that it has to be that way. Ever, all right, here. So we got to artificially counter spin it. That's okay. Not all the time, but oh man, I see some pretty cool stuff with this. So I think I can do a 24 volts right now. I've been dying to check it out and see what it's all about. But yeah, my hand hurts. All right, let's see here. It's a legitimate fear that my hand won't be able to stop it. Alright, so no, we're not going to do that right now. Oh man, but I will set it up for the next one. I literally have to take it apart to put it back together. And that's okay, but it's going to take some time. And I'm going to need to be in a much more comfortable position to undertake that. That'd be cool though. It's going to be cool. And I'm really out of it, man. I've been rearranging my room here for the past 2 days. Kind of like lifting heavy stuff for 2 days, and I'm tired. Non-stop, like just trying to get it all done. Oh, it's great though, man. I feel like when I fall asleep, I'm gonna have the best sleep of my life. And it's that kind of feeling, you know? And what's cool is all these circuits on the top, or the drive circuits, are independent of the drive or the pickup coils. And yet every single drive coil that hits is affecting the same pickup coil because they're connected in series. So it's like boom, 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 boom. I haven't found a negative with how it's set up yet, except its appearance, which I think is shaping up even as it is, man. If you get the aerial view, it's not that bad. It's really kind of neat. Oh yeah. And then the ice just swooped in from whatever direction it came from, and yeah, I twisted my ankle in the ice, and I'm like trying to clean it out, and oh man, it's just been heck yeah, oh my god, this the funnest, most terrific week of my life. I had just had my birthday. That was awesome. Yeah, I did a live stream on my birthday, and we had a blast. Heck yeah. So the paradox here, and I don't know if it is a paradox yet, because I haven't swapped the pickup coil and the drive coil. I've always had the drive coil on the outer edge because I know, and I don't know this anymore, but I knew that the 28 gauge strand in there wasn't going to be able to generate at 1.5 inches what I needed to turn on the circuit to begin with. But I might be totally wrong about that. So that's another thing we can look at, is swapping the drive coil and the pickup coil, so it'll get way more magnetic energy from it. You know what I mean? That's what I'm thinking about when I'm looking at this. I'm like, what's more important? And if it can, trigger from that distance, then yeah, it would be advantageous to swap them. Then you might even be able to run this thing the way I want it to run, and that's with my hand starting it. But I think I'm going to need the super caps before that's actually going to be a thing. But this is pretty close to a super cap. This cap bank that's on here right now, it's better. It's got AC and DC caps, and then it's got 4 bridge rectifiers on it. and it can do up to 1200 watts, 600 per side, so maybe 600 watts positive and negative flow. You know what I'm saying? Like it's all right. Oh yeah, man. All right, so boom, boom. I love it, man. We're getting so much energy, and but that energy is coming from the, I don't know, what is it, the induction, the EMF, just from being in proximity to the drive coil is where all that energy is coming from. And you have to have battery power or some kind of power going through it in order for it to generate a reaction like that. And that if you don't have that, you get a smaller reaction, which is barely enough to make it work. But I'm thinking that if I switch the coils around, that reaction will be that much stronger. That should be really awesome. Yeah, and then like maybe putting two more, like have them be combined, have two, because they really can't get any closer than they are. Not too much, not without it being like unsafe, like really unsafe. That wall right there would be really thin. But to like double them up, I think that would work really, really awesome. And way back when I started building this thing, I'm like, I don't think one magnet is going to be enough. And I said that from the beginning because I was using two magnets when I was, what am I trying to say? Before I built the Utron, and this was just on the pole and everything. We can do that still. I can remove the Utron. We can put some bigger magnets down here. I have bigger ones. But that it's not important. What's important, I might hook up to 24 volts. I need to print off that plate. I need to rearrange all this. I think it's good, and it's getting better. Heck yeah. All right. But now we'll turn that off. We'll turn this. All right, we're going to try and get our clips on this time. All right, because here we go. Some readings. Wow, dude, 20 volts. 20 volts. That'll get up there with, and that's after all this time. Now it's at 18. So it was up there, maybe 30 volts or so. And that's a lot for these little coils, man. I mean, they're tiny little coils, and it's just from it pulsing. So maybe 30 or 40 volts DC stacked up in the cap bank there. But, all right, and then we can make it chirp, I think. No, not that time. It wasn't in the right position. But if it's facing a magnet, it'll chirp. All right, so. Yeah, I don't know what I'm trying to do right now. I don't think I have enough oomph in my arm for it to, like, get ahead. You know what I mean? It's always gonna, as soon as I let it fly, it's gonna start to slow down. And that's why I don't, maybe stronger magnets will work. I'll like give it at least enough so that it, and I'm not talking about it continuously increasing. And you would think that because there's no human involvement, that's what has to happen. It has to continuously increase. I don't believe that. I did almost have an SSG like run away on me, literally. It was going so fast, and then it just wouldn't slow down, and it kept on going faster. And it was just to the point where it was like, not safe. But it was probably because I didn't have the pot hooked up. And there was like right there in that sweet spot where it just kept on increasing in speed. And that's how I got all these marks on my thumb. I like tried to stop it and it went like this and just skinned my thumb. It was not good. Yeah, sometimes. Sometimes. I keep on wanting to tell myself I hear something, but I know I don't. Maybe I do, just a very faint one, like a chirp that's so faint. It's awesome how the one circuit just feeds. And it's weird. It's not like a direct feed, like a Bedini SG feed. It's like what happens is it chirps, and then the coil, the pickup coil, picks up that imprint. It's so neat. I just love how this thing works. Because the pickup coils are in no way physically connected except through all the cap bank to the circuit. And there's no load, there's no like lens load or anything, like there's no load. effect. I mean, I would say that the load is the other circuit. For the first circuit, it would be the other circuit. And then if I wanted to, that's what I'm probably going to end up doing is feeding the next two circuits with these circuits. I don't know how much juice it's going to take to run 4 circuits, but we'll see. That's so cool, man. And it's holding together pretty well. I know it looks really rickety, but it's holding together pretty well. And those wires are the only thing that are clipping me, and they're like little kids holding onto the Ferris wheel going really fast, and they're kicking me. Mm. Mm. Thank you, thank you, thank you, thank you. Then I got the other motor running over here, and it's charging. See, when I take this off, I got another rotor under here, and it charges the cat bank. And the cat bank runs both motors until it runs out. And then we just start the whole thing over again for right now. And I try to hook up, different things and see what works. I got the bridge rectifier over there. I got another cat bank right here that link them all together. And then I got the piezos. Those are the new edition in series. So they're in series with each other, but they're across the coil parallel. I think that's the best way to do them in series and then the parallel. I think parallel is kind of the only way to do them really, because I hooked it up series on the line and it totally shrieked me out, man. It was loud. Not normal for a piezo. So if you put them in parallel or in series parallel across the coil, that's where the magic happens. And then you can put them just regular parallel across the coil, meaning 1, 2, or you can hook them in series and do 1, 2. But it's good to use them in pairs as well, at least 2 of them, so they work on each other. I mean, that's the basic idea of using 2 of them. And you can use more of them than 2 in series across the coil. So yeah, that's really cool. And let me think here. Can I do this without, maybe. Without running this rotor, can I force the energy to go through? And I think I can. You can hear them clicking already. All right, here, we'll watch this. doesn't look like it's filtering through. Oh yeah, it is. There it goes. Well, maybe not. There, kinda. Yeah, without the rotor over here, it's really slow. But without the load, the piezo's are like off the charts. Listen to that. I'm using my Litz wire coil with the trigger strand. They're just the same. Drive and the trigger are all wrapped up in one, and they're the same length. 26 gauge. And they're still pounding. Power's off, and they're still clicking. Yes, air core. I love them, man. That's so cool. And then you turn that down. This is still up at like 4.5 volts. The kickback to the power supply, man. That's a lot of voltage. Mm. But I think in order to really get this off, we need to switch out the rotors here. Hey, what's up? How we doing? Thank you, everybody. Appreciate the likes. Appreciate you hanging out. Yeah. Mm. Wow, dude. That is amazing. Freaking amazing. Wow. Unbelievable. This is a counter rotating Utron pulse motor generator smorgasbord of clips, wires, transistors, light bulbs, cap banks, and coils. And it's awesome how well that combination of stuff works together. Demonstration. Whew. Oh yeah, man. I got 2 more circuits to put on here. Or 1 more circuit in series. I think I'm going to do 1 more in series. What I'm going to do is I'm going to hook up the front coil and the trigger coil. Trigger coil is going to be hooked to the transistor, and then the end of this other coil will be hooked to the transistor instead of the end of this coil. Blah blah. Not can't explain it right now, but it's just a series connection where the trigger coil and this other coil gets wrapped into the drive instead of being used as a trigger, and they're all connected to this one over here in 180. So when this one hits, this one's going to hit, and it'll work just the same because it's 2-phase really that works on it's a 3-phase stator with a 2-phase rotor. Because I can see this 180 and then this 180. And it doesn't look like any 180 is going to be on at the same time. Maybe it's just 1 phase then. I don't know. I don't know. But I know that having that other motor or that other coil hooked up to the other circuit will definitely be causing more pickup on the pickup coils. And then it'll complete the pickup really, because it'll be, right now there's, even though that the one circuit's working off the pickup coils, it's still pulsing one of these drive coils. So that pulse is going to hit the pickup and it's going to go back into the cap bank. Now I do believe that that pulse is less. It's always going to be less than what you put in. As far as I've experimented, it's always going to be less. That might be bullshit. I don't know. But maybe at a high frequency. Now, if I had a way to manipulate the freaking frequency on this thing, that would be dope. That would be splendor. That could move mountains. I don't know. Just kidding. Actually, I've played around with frequency quite a bit, and I think that if I can manipulate the frequency on this, that I could generate more with the pickup coils than I have to put in to the drive coil. And what are we putting in the drive coil? In the first circuit, we're putting in 12 volts. Are we using 12 volts? Hell no. Oh no, we're not using 12 volts to run that circuit. Not a chance in hell. What it's going to use? I don't know, actually. And what is it going to send on to the next one? It's not sending anything on right now. The second circuit is run completely a different way. But it's only going to work currently if the battery operated circuit is functioning, because the pickup picks up off of that energy, and in order to get it to run at any sort of chirp, you gotta have that battery circuit energy in there. But if it gets going really fast, you'll generate enough probably to chirp every other time, which is a lot. I'm just saying. Every other revolution, you'll be able to hear it go chirp, but it's already chirping. So it's like, all right, when you have them both running at the same time, they both run at about equal efficiency. The one that runs off the pickup coils might run at a higher voltage, actually. Actually, they might run at a higher voltage. I can't really tell that one. Yeah, that one's harder to figure out. I like to think that's what's going on, though. Nah, it's a pulse motor. You can call it whatever you would like. Yeah, that's starting to hurt, man. I mean, I'm not really, but it's like whipping me. So I'm thinking I'm gonna hook up those next two circuits. Generate between, and I mean, when that, see, this is why it doesn't really count, because when that cap bank is closed off on the end, it can get up to 120 volts easy. Yeah, at least wear some glasses. Speaking of that, I better put mine on. So, I mean, these magnets are really strong. Wow, did you hear how like weaker that side is? I don't even know, man. That's kind of weak. Let's see. Wait. So now the cat bank circuit is on, and the first circuit's closed off, so none of the battery juice is flowing. And the second circuit is, left to the devices of the magnets. So this is eventually going to stop, but I think it'll go faster than if I just had both switches off, or it'll go for a longer period of time. Because once I knew that the pickup coils were actually doing what they were supposed to do, I knew that this was working. It just was working at the voltage that I was generating with my hand, which isn't very much. Yes, sir. I'm very much trying to control, at least being able to turn it on and off. Um, Maybe not so much the speed. Maybe I'll have a speed knob on it too, but I mean it's solely I just want to run the two toggle switches with the remote right now. Because that way if it's going too fast I can just kill the power. Now I'm going to spin the center alone without spinning the top, or I mean the Utron. Now see, when it's counter rotating, I believe that it's working. Okay, so when it's going this way, I think it's on. When it's going the same way, I think it's not on. And you'll see it'll switch. Now this is going against the grain. There's a lot of magnetic batteries in the rotor. That's just what I think. I don't know if that's actually happening, but I'd like to think it is. So counter rotation means it's on. Same rotation means it's off, and it's not working. Yeah, there's no way that it can't be working because I'm going to turn it off and I'm going to spin it again. I don't think it'll move anything like it's been moving. It's hard for me to tell though. Off my memory real quick. And then when it gets down to a null rate, what was I going to do? Turn it off. That's right. Okay, so I was wrong about that. Yeah, I think in order to get the action from the magnets that I need to get, I either need to swap the coil's position or I need to get two magnets or bigger magnets. And I don't think I can really get bigger ones this size. Or the size is good. They need to be deeper. They need to be in more depth. Oh no, this is the same old one. That's what I'm working with right now. Boom. So that I got two of those in there right now. And they're hooked up to this coil and this coil. So you got your battery or your power supply, and you got your coil, you got your MPN, and you got your light. Huh. I don't know, man. I think the cheapest, easiest way to do this is just going to be to swap the coils and hope that that 28 gauge strand is enough to trigger. It'd be interesting to find out if it is. Because I know that the pickup coils are going to work the same way, whether they're in front or behind the coil. Right now, they're all behind them, and they're picking up the energy from the back. You put them in the front, you just have to put them, you know, what am I trying to say? The appropriate polarization is going to give you the most energy. So if they're good right now, so if they're both facing front, it's simple. You just move this one in front, facing front. Bam. But you know, I think it's working pretty good right now. It's just not getting the magnetic pickup that I would have liked it to. So yeah, and right now, even right now, you got to whip this thing pretty good to get it started. So I'm not really hopeful with that change actually. See, let's see how much you got to do. See, that's not enough. So you got to whip it pretty hard, and I'm thinking that without I mean, I don't know for certain. Haha, I'm good. Don't need no booms here now. No, we don't need any of that. Piezo's, ladies and gentlemen. So when I get the other rotor going, the transference of energy into the cap bank is pretty smooth. Not this cap bank, there's a super cap bank on the other side of that piece of wood over there. And I like charging that up. Here, let's hook it up. Yeah, it's not right. Okay. It's working though, but you need the other rotor in here. Because it's all one big connected circuit. And it just won't work without it. But I have everything dumping into the cap bank, and then when I plug those two clips in, I'm now spending from the cap bank. And it works out pretty good. It lasts for about an hour. Pretty smooth. Because I just switched it back, and now you know what? Wow, it's like 4.5 pounds. 2.5 pounds of copper. Doesn't really look like that much, does it? Yeah, the pot's not hooked up right now. I mean, I know I see it chilling there. I'm thinking maybe it should be, but it didn't work too well with the piezo's. Only 3/4 of the pot didn't work, and that 1/4 of it would function. So I took it off. Yeah, see, there's something with the. Let me try this. Might have to upgrade these transistors. Or maybe the other one's blown. I'm not sure, but. Sounds sick, doesn't it? I think I'm gonna have to give it some sort of patchwork. I don't know if this is what the problem is. God, it's so hard to see with this light. Mm, looks good. Huh, that's weird. I want to know where that's. Hmm. 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 Yeah, I'm just tinkering. You guys can stick with me if you'd like. I don't mind. I knew it, man. The diode blew out. It's amazing, man. It's a 3 amp, 1000 volt diode, and they're blowing all the time, man. Rectifiers. There we go. Yeah. Yep, and we're charging again. That's awesome. See, there was a break in the line. I just had to find out where that break was. Yay! I got it running, and it's working. I'm gonna let it run for a little bit, charge that cap bank up. Doesn't look like there's anything wrong with this. I had one of my LEDs lying around somewhere. I think they're in the shed. I'm gonna grab one of those and try and use one of those as a diode. It'll even look cooler. So I don't know if this is gonna Ooh, 9.92. We're gonna try and get up to just 10. And then we're gonna switch it from the power supply to the cat bank. I think I'm gonna use one of these UF 4077s. There you go. They're both running on the cat bank. I love it. Nothing too fancy. Of course, the cat bank is dwindling, but I'm not too worried about that. See? Yeah. So the cat bank runs that motor runs this motor, and this motor charges the cat bank. Something like that. At least that's how it's hooked up. And yes, it's not enough to stay ahead of the drain. In other words, it costs more to run it than it does generate. So it doesn't really. It's not really set up to generate anything really. Just to let it pass through. So it starts there, it takes whatever it needs to run that, then it will runs to this one, and then takes whatever it needs to run this, and then the rest of it goes into the cat bank and starts the cycle again. Which of course, haven't found our way around that. Not with this anyway. Not with like this standard DC brushless motor. And you can see right there, just barely, but the energy is passing through this cat bank. And that is the meter of this cat bank over here, which is running everything right now. The reason why I'm disclosing that there's a cat bank over here is because I'm not trying to pull a fast one on you. This is what's powering everything right now, and it's being charged by everything right now. It's just the charging is lower than the running. Yeah, man, it's cool though, man. I love doing it. I'm not trying to prove anything. I just set it up so that I could watch it go down. I said that before I set it up. I'm like, we're gonna watch it go down. It's gonna take a little bit. Mm, mm. Before you go and tell somebody to spend, $150 on copper, that you should do it yourself first. And some people have, and I agree with you. Big coil, big punch. It takes a lot of voltage to run a big coil too, so you need more voltage, and that's always fun. But I mean, right there, we're talking two more batteries that are at least 12 volts that you would have to hook up in series to get 24. And then if you wanted like 48, you'd have to get two 24-volt batteries, hook them up in series. You don't want to go like 4 batteries, I don't think. That's taking up way too much space to get to. Just, you want to keep it. I mean, even I don't do that. That would be like way too much space. You want to do it in a different way. And then you could also get one of those multipliers where you put a DC voltage in and you can get up to like 345 DC volts out. And yeah, it's probably taking a sweet lot of ampage, but at least the voltage is real. All right, we're dwindling now. We're at 6.5. Still moving pretty good for 6.5. Thank you, everybody. I really appreciate it. But I'm like really tired. Thank you, sir. Appreciate that. It's one big loop. That's what it is. And it starts and ends right there. That super cap bank. Well, we're starting to spend a lot slower. Everything's about to shut off, though. Okay, as soon as this comes to a stop, I'm gonna set up the other rotor real quick. That's it right there. That's part of it anyway. All right. So I'm going to put you guys back up in the tripod. I noticed that the pesos didn't fire when I was running it off the cap bank. They're running now. I can hear them now. Maybe they were running it, I just didn't hear them. All right, and to close it off for the night, I'm going to spin this one more time. Thank you very much, ladies and gentlemen. Peace out and have a wonderful night. I don't know. We'll see. All right. Maybe we'll spin it one more time. So you turn both circuits on, and it comes. The battery runs the one circuit, and then the pickup coils run the second circuit. Fair enough. Both circuits will run when I turn this on. You can hear both of them go. Oh yeah, the tape's flying off. Little markers flew off. Come on. The wires from the two coils I don't have hooked up yet. And then there's a couple battery wires that are just chilling, but that's about it. Everything else is kind of glued down. So like this right here. These ones right here. Yeah, it hurts kind of, you know? And like I've been saying the whole night, this isn't a final build by any means. I just like to know that I can take it apart and put it together whenever in the process I want to. So that's basically why I'm doing it like this and dragging you guys along. Part of me likes to think that you guys like tinkering. This is part of that. I mean, the first one I built, I was sure I had the measurements right, man. Like 100% sure I had my tape measure and everything was measured out to a T. Didn't fit at all. Didn't fit at all. And it happens. If it hasn't happened to you, you get perfect sleep and you've never made a mistake in your life. If it hasn't happened to you, congratulations. But you know, I'm a real person, and I like doing things a step at a time. I don't know. That was kind of blah blah blah. I'm getting tired, so. But I do think I'm going to run this last circuit in a parallel fashion with the other 180 coil. So these two will be hooked together in a single circuit. So there'll be 3 transistors, 3 lights, 4 drive coils, 4 pickup coils. It's going to be awesome. But there's really essentially going to only be like one of the pickup coils is going to be a single bifilar, or one of the drive coils is going to be a single bifilar. One of the drive circuits is going to be a series bifilar, and the other ones are running off of the pickups. So each one's running a different way, which I like. And each one is different, which I like. Because essentially there's only so many things you can do. But I think I might switch the drive coils to the second coil and the pickup coils to the first coil. Or I'm going to double up the magnets, or I'm going to do both. But before I double up magnets, I'm going to need to print another Utron base that is built to hold the 2 magnets. And then on this one, yeah, and well, with the 2 magnets, I think for sure it'll be enough magnetism to reach to the second coil. Because right now the second coil is 1.5 inches away from the magnets. So spinning the magnets isn't going to generate much for the pickup coils the way they are right now. It isn't going to do much. You can spin it really fast, it isn't going to do much. It will do much the faster it spins, though. The faster it spins, like the more magnetism, the field will be expanded and you'll get a bigger reading. But it's got to be going pretty fast for that to happen. Faster than I can push it right now. So is it running itself questions, is it doing all that? No, it's not. No, it can't. Not the way it is right now. I had 2 ideas that might, help change that a little bit, not all the way, but just make it run better than it does right now. Here, I'll show you what we got right now. See, pretty much nothing. No chirp. But when I turn on the primary drive and it's chirping and it's hitting the series circuit pickup coil, oh man, it lights up. The lights light up right away, and you immediately have voltage to play with. I doubt we're even getting a volt right now because of the distance between the magnet and the pickup coil. It works just fine for the drive. The drive is in the right spot, which means I kind of don't want to move it back, but now the cap bank is empty right now. But when I spin this, it's going to light up pretty quick. All those chirps stacking up in the cap bank. See, look at how red those lights are. Look at that. There's a lot of energy in there. So that's how I know that when I turn that switch on, that all that power is surging through the second circuit, and it's running and it's working. I know that because of what I see here. See, watch, I'll turn it on. You heard it chirp, and all that energy flows through the second circuit. So yes, man, this is awesome. We are that close, I feel, honestly. I'm still in doubt, but we are like this close. Even though I'm doubting that this thing will be able to do what I want it to, we are close. I think if we switch the pickup coil to the front and the drive coil to the back and double up the magnets, we got something that works and does exactly what you think it does. You know what I mean? So that's two circuits that run off of one, basically. And if that one that's running off the pickup coils can run any better than it is right now, I might be able to start it with my hand. If I can start it with my hand, especially when those super caps come, man, I'm going to hook up super caps in place of the batteries. But this apparatus right here with all the caps on it, about as good as you can get for changing AC to DC. But yeah, thank you all. Peace out.